Okay, so this video is going to help you understand calculus a little better and just the fundamentals. And all calculus is finding a rate of change or a slope of a graph. If we had a line and you had the equation in the form of y equals mx plus b, hopefully you could all tell me that the slope of that line would be m, whatever that number being multiplied by x was. But what if we had a graph like y equals x squared, where it's curved? And obviously the slope is different at every given point. There's no common slope. It's inconsistent. And we could take two random points and try and find the slope between them, y2 minus y1 over x2 minus x1. But that wouldn't give us an accurate representation of the graph at either points. And what we want to find is not this secant line, but a tangent line between a point and the point right next to it, so close that it's immeasurable. That's called the tangent line, and that's what calculus is. That's where we find the actual rate of change. So we want to have some function here, and we want to take some x here and some other random point here that are so close, and we want to make that distance closer. And we'll call the first point just x, f of x. And f of x just means, it's another way of saying y. It's what you get when you enter in an x to an equation of a graph. And our other point as x plus delta x, right? And delta x, this is just a little extra. So this point is the x we've gone plus a little extra. I'm using just a generalized form here so that we can get a equation that we can use again and again. And so it'd be f of x plus delta x. And so what we want to do is we want to set them up as in our equation, right? Just like before, f of x plus delta x, right? That's our y2, minus f of x over x plus delta x minus x, alright? So these cancel out. We're just going to be left with delta x on the bottom. Now, we want to find the exact slope. That's what calculus deals with, finding the exact rate of change, because in life most things are inconsistent. I mean, when I walk or drive, I don't constantly go the same speed. It changes. And so we want to use what's called a limit, and it's written, representation is written like this. As delta x, that change in x approaches 0. We want that change to be so close to 0, just as, and the limit means as it approaches, it gets infinitely close to where we can't even measure anymore how close delta x is to 0, how close these 2 points are to each other. And so, but we can't just plug in delta 0 for delta x right now, because we're going to get 0 over 0, right? It would be f of x plus 0, or just f of x minus f of x over 0. And 0 over 0 is very bad. That's something you want to avoid in math. So we don't want to do that. What we want to do, though, is we want to go ahead and multiply this out, right? If y equals, let's do it for y equals x squared. So we'll get the limit, remember, as delta x approaches 0 of, for x squared, it's going to be x plus delta x squared minus x squared over delta x. And this right here, this limit idea, this is key in calculus. This is the fundamental key idea right there, that as delta x approaches 0, finding the slope of any given point on a graph, no matter how crazy it is. And you can use this for linear equations, and you'll get that the slope is still the m. Alright, so back to this. We're going to FOIL the top and get x squared plus 2x delta x plus that delta x squared minus x squared over delta x. And this may look like a lot, but these x squareds will cancel. And it's about to get a lot simpler because there's a delta x in every part of the equation. So we can factor that out and say delta x times 2x plus delta x over delta x. And for those of you, if you see it, delta x can cancel out because delta x over delta x is just 1, right? And since it's being multiplied on top, we can factor it out and then just divide it out. So now we're left with 2x plus delta x. But since there's no more division, we can substitute in 0, right? Because that's what we want. We want delta x to equal 0. So this is really just 2x plus 0 or 2x. And that is our slope. That is the slope at any given point on this, right? So this is the derivative. You're going to hear that term a lot in calculus. And all that means when someone says find the derivative is find the slope, right? We're looking for slope. That's what calculus deals with, is finding rates of change and relating them. And it's not really that hard. There's a lot of rules. People have already done the math. A lot of ways to make it simple. So what does this mean, 2x? That means that, say we have a point on our graph, y equals x squared. Say x equals 3. Then that y point, okay, if x equals 3, f of x equals x squared, then f of 3 is 9, right? And so the f prime, or the derivative, that's how it's written. You'll also see it written as dy over dx. This means change in y over change in x, equals, in this case, 6. So at any given point. So at the point 3, 9 on the graph, x y equals x squared, the slope is 6 at that exact point. And that's all calculus is finding rates of change, no matter how inconsistent the graph is, no matter how curvy or such. And so that's it, really. That's all there is to calculus, is finding the slope and the rate of change.